The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hello and welcome back to the Ben Heck Show. In today's episode, we're going to build something I've been thinking about doing for quite a while now. I want to make a seeing eye hat. Basically, a hat that a blind person can wear with ultrasonic sensors and rumble motors on it so they can sense or feel when they're getting near objects. I think it'll be a really cool project. Let's give it a shot.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
Let's go over the parts. Here is a lithium-ion battery, 3.7 volts. It's actually more like 4.1 when it's fully charged. Here is the charge circuit for it, so we can charge this hat using a USB cable. This is a Parallax propeller development board that my friend Parker Dillman, the Longhorn engineer, designed. He sent this up to me, so I'm going to use it. And Ken Gracie from Parallax sent me a bunch of these. These are the Parallax ping sensors. They're basically ultrasonic sensors that can detect distance up to 6 feet and as close as a few inches. And then I have a whole bunch of these miniature rumble motors. These are the rumble motors that come out of the triggers of the Xbox One controller. When I make single-handed accessibility controllers, these usually get taken out because there's no room for them. So I have a ton of these little motors laying around. They'll be perfect for a hat sensor. I 3D printed these pieces. These pieces will both hold a rumble motor and the sensor. So we can basically glue these around the hat. I'm going to screw them in place. Then I'll put the rumble motors in. And I should have grabbed the short screws. Darn it. Never mind, I guess I did need the long screws. This is terrible. No! I tested the motors on my multimeter or multimeter. They take about 50 milliamps at 3 volts, which isn't too much. You could probably even get away just direct driving them with your microcontroller, but you really shouldn't. Microcontrollers have a small amount of current they can source or sink. So what we're going to do is just go through a NPN transistor. The positive voltage goes into the rumble motor, then the other side of the rumble motor goes into the collector of the transistor. The base of the transistor is going to be connected to the microcontroller. That's what will actually control it. So when you apply high to the base, the current will flow through the transistor. So the transistor is sinking the current instead of your microcontroller. And I just have switch it on, test rig here. We might also do some PWM, pulse width modulation. So the closer you get, the more it rumbles. So like like a submarine. How about for every episode I watch of Game of Cards, you watch The Office? What do you think?
Game of Cards.
Game of Card Thrones. No. That's many loose now. You know what this calls for? Funky Foam Incorporated does not pay me. I wish they did. I would take their money. Who are you? I am Locutus B. Foamus, CEO of the Funky Foam Corporation. We've been watching you, Mr. Hackendorn. We've got an offer you can't refuse. He's gonna have like this gigantic fireplace with a picture of himself over it with like a big rifle and like some sort of wild animal he shot in Africa. And he's gotta have his foot on the animal. Like a Teddy Roosevelt kind of shot. I'm gonna see if I can feel the vibration through this hat. Yeah, I definitely can. I thought about using maybe like a headband because it would press against your skin more. But this is probably, you can definitely feel it. You can use it to massage your neck. Ah, my Thetan trigger points. That's like a Sky Mall item. The sides are pretty straightforward. It's the front and the back I'm more worried about, because if you put it right here, the can's gonna be pointing up, whereas they should be straight out. But maybe they could be right here. See, now that I can't feel. Maybe if I attach it to the bill. Hey, I need your head. With the help of Allison, the head model, we have some good positions to put these sensors. I'm just gonna hot glue them in place. That way, maximum vibrations are transferred. Usually you don't want vibrations to transfer. Today, we want vibrations to transfer. And we want them to be good vibrations. You've got the good vibrations. Come on, come on, come on. Imagine if you were a time traveler from the year 1990 and you came to the year 2014 and you looked around and Marky Mark was starring in 3 movies a year. You'd be like, no! It'd be worse than waking up in a post-apocalyptic hellhole. Of course, in a world where Marky Mark is in 3 movies a year, maybe we are in a post-apocalyptic hellhole. I mean, he's a decent actor, but why? I guess there was a reality show called Wahlburgers, where him and his brother were making hamburgers and they had a restaurant. Hey, you know, it doesn't actually weigh that much. I can barely tell that I have sensors on my head. That's my Halloween costume. I'm gonna be a Google Street View camera. I have a spare Parallax ping sensor hooked up to a Parallax propeller development board, as well as a normal motor. I found a couple libraries, one to do the ping sensor and another one to PWM the motor. And it's going to look for any range of 50 inches or less, and then it will turn that into a PWM pulse. So you have to have at least a 10% PWM before the motor will even spin, so it's going to start at 10 and then go up to about 70, depending on how close it is. So I'm going to simulate a wall being close to the person. It's moving a little bit. And the closer I get, the faster it spins. Sometimes it spins so fast the tape flies off. I also set it to have kind of a lower frequency because I wanted it to be more of a than a, because it's more about getting your attention than spinning a motor at high speed. Nope, don't spin. Please no, spin tomorrow. Well, you got the example. Okay, so I have to take this and multiply it times 4 sensors and 4 motors. So that's what I'm gonna do next. The ping sensor requires 5 volts. So unfortunately, we can't run this with our lithium-ion battery. We could do a boost converter, but I think that's kind of overkill. So we're just gonna use 4 AAs, so we'll get 6 volts, which should be fine for the ping, and then we'll add this 3.3 volt regulator for the propeller and the motors. Now it's time for a tech timeout. I finally bought a new cell phone. I got the Motorola Moto X Gen 2 with rich Corinthian leather on the back of it. Yeah, so of course, new cell phone. I have to make a new cell phone stand for my computer. So I designed this and 3D printed it. It's in 2 parts. There's the upper shell, which holds the phone. And then of course has funky foam around it. So what I do is I take the measurements of the phone and then I add 0.075, which is the thickness of the funky foam, and then I design my shell around that. So I can take my shell, line it with funky foam, so the phone touches the foam, say that 5 times fast, instead of the plastic. I also found this, this was on Amazon actually. It's a short 3-foot micro USB cable, and the trick is it has a right angle plug to it. See that? If you have a regular USB plug, you know, that sticks out like this, if you put that into the base, it would make the base unnecessarily tall. The right angle plug allows you to have a much shorter base, see? So let's put this together. So this fits in here, and then the cord comes out the back. That way you don't have to cut the cord. And then there's these posts. They're probably kind of hard to see since everything is white. And they fit into holes in the bottom of this to help line it up. Now I'm gonna check the fit of the USB cord first before I glue anything together. All right. One thing about this phone that's kind of confusing is it's symmetrical, so if you're just looking at it like this, you can't really tell which way's up. Oh well. Okay. Make sure that's right. Of course, some hot glue. Fill that cavity there. Which reminds me, I need to go to the dentist. Make sure there's no glue on my fingers. Insert the phone. So I can just plug this right into my computer so I can charge it and get data off of it in the same shot. How would you feel about hot glue making your head warm? Is that okay?
Yeah.
Okay. There's a pretty good chance it won't stick to your hair. Well,
You know how that goes.
I'll put it right on the seam. You okay?
Yeah.
All right. How many times are we going to turn Felix into a cyborg on this show? That's my question. Okay. All right. No more torturing Felix. I'm going to attach the resistors and transistors that I need in order to drive the motors and sense the distances. The ultrasonic sensors operate at 5 volts, so we have to put a resistor in line so they don't damage the inputs on the propeller, which is only a 3.3 volt device. The ping sensors have all been wired with power and ground. Now I'm going to attach their signals to the propeller, and then I will attach the rumble motors. All the connections have been made. Now we need to program it. The hat is all programmed. We're using a Parallax propeller as the main microcontroller. It's a great choice for this project because it has 8 simultaneous cores. So we can have one core for each direction, that way there's no interruption. And each one updates at about 100 hertz. So what happens is it sends out a signal, then it times to see how long it takes to get back. And if it's within 6 feet, like if a wall is 6 feet or less away, the rumble motor will pulse. And the faster it pulses, the closer the wall is. And you'll be able to feel it on all 4 sides. So you can tell if you're going between 2 walls or if you're about to run into a wall. And there's also one behind you in case like a truck or something is behind you, or a rhinoceros. So that probably wouldn't happen. But if it did, you would want to know because they're dangerous, but apparently not as dangerous as a hippopotamus. We have a 6-volt battery pack here. We need 6 volts in order to drive the ping sensors. They don't work off 3.3. We have transistors here to drive the rumble motors. There's a power switch which turns everything on. So what I'm gonna do is I'm gonna put this on my head and try to navigate my shop blindfolded. And it's a good test because we've only been here for about 3 weeks, so I don't really know where it is. It's not like when you get out of bed in the middle of the night, it's dark and you know how to go to the kitchen. We haven't been here that long, so. Okay, it's time to test out the Seeing Eye Hat dog. Don't pet it. Luckily, Allison has, no joke, 1 billion scarves. So I can use one as a blindfold. Okay, now I just need a piñata. All right, I'm gonna switch on the hat. Make sure the sensors are working. Okay, they're all working. All right, I'm going to just walk around my shop. I can hear my 3D printer, so I kind of know where I am. I'm assuming the CNC machine would be over here. Yeah, I think, oh, I heard something. Come on. I guess I can keep walking forward. Oh, there's my, okay, I'm picking up the CNC machine on my right sensor, which means I have to turn this way. Oh, okay, so I can feel my desk and the wall. This should be my wall of parts over here. Oh, yeah, there it is. There's all my bins of parts. Okay, and there's my computer. All right, so if I turn this way, okay, I can feel the wall behind me, so I can walk away from it. I'm picking up something in front of me. I wonder what it is. All right, oh, I heard my cell phone. That was a text message. All right, I'm gonna try to walk through the doorway leading to Allison's office. Why do I have my hands out? I guess it's just human nature. I have to be brave. Your favorite Pixar movie? Oh, okay, all right. Okay, I can hear the door jam. Yep, there it is. All right, now I'm in Allison's office. Look, Ma, no hands. Her chair should be here. Yep, there it is. Hi, I'm Allison. I like kittens and tofu. This actually works pretty well. This episode's challenge was to build a hat that would allow blind people to sense the environment, kind of like a seeing eye hat, and we managed to do it. It actually wasn't that difficult. So I'm pretty happy with the result. Things I would do differently, maybe use smaller and less expensive sensors, make it all in one, make it more of a headband, so the feel is consistent around your head, because this obviously does not touch your skull as well as these do. But, it worked out pretty good. Do you have any ideas? How would you have done this? Let us know at the Element 14 community. Well, that's all the time we have for today. In our next episode, just in time for the holidays, Santa Ben is going to bring you what you've all been asking for, an Xbox One laptop build. We'll see you then. All right, I'm going to disorient myself. You kind of look like a VR zombie. It's like you're in a murderer's dungeon and you have to find the escape door in the dark. If you walk outside like that, the neighbors are gonna think you're crazy. They don't know the half of it. That's a drill. Water, Helen, water. All right, turn around 180 degrees. Okay, try that. I think I did a better job than you did. That's right. I got it all. I recorded everything. Hey, Moto X. Oh wait, it's not Google Now. Okay, Google Now. Go to element14.com. Do you think it'll work?
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.